So now that we have the basics down of how we are going to perform a test of significance for population proportions, and we have our acronym of phantoms that we're going to use in our state plan do and conclude, we're going to walk through an example together. Have your calculators handy so that we can try it together and make sure that we know how to do it on our own. So, on shows like American Idol, contestants often wonder if there is an advantage to performing last. To investigate this, a random sample of 600 American Idol fans is selected. That's important. And they are shown the audition tapes of 12 never-before-seen contestants. For each fan, the order of the 12 videos is randomly determined. Thus, if the order of performance doesn't matter, we would expect approximately 1/12 of the fans to prefer the last contestant they view. In this study, 59 of the 600 fans preferred the last contestant they viewed. Do these data provide convincing evidence that there is an advantage to going last? Okay, so the first thing that we need to do is we need to say what in the world we are going to do for this problem. Notice how it doesn't say, please perform a significance test to test this claim, right? It just says, is there convincing evidence? In our last chapter when we were doing confidence intervals, it clearly stated, please construct and interpret a confidence level or confidence interval. This chapter, it's not going to explicitly say that. So when it's asking if there's convincing evidence, we kind of have to know in the back of our head, all right, the appropriate thing to do here would be to do a significance test. So the first thing we're going to do is we need to state. Okay, in our state, we need to say our hypotheses, what alpha we're going to use, and then also talk about our parameters. So what we want to do in this problem is we want to test the following hypotheses at the they didn't state what significance level to use, and so in that case, we're just going to go to our default of using 0.05. So we want to test the following hypotheses at the alpha equals 0.5 significance level. So we have to have a null, and we have to have an alternative, an h sub 0 and an h sub a. Now, this is a problem for proportions. So P is going to be the parameter that I use. It's not mean, it's not mu. And then our null is always some kind of equal. So we would, like how it said, we would expect approximately 1/12 to prefer the less. So P is equal to 1/12. If you want to go ahead and convert that to a decimal, by all means you can. And then for the alternative, we want to say, is it preferred? Meaning, if they prefer it, you would expect the proportion to be greater than 1/12. Okay? So we have our hypotheses. We need to find that parameter. What is P in this case? Well, P is the true proportion of American Idol fans who prefer the last performance they see. Notice how I'm saying the true proportion? Because it's for the whole population of American Idol fans. True proportion of American Idol fans who prefer the last performance they see. Okay, we are a quarter of the way there. We have taken care of the parameters and the hypotheses. Next step, we need to assess our conditions and also say which tests we are going to do, right? Which inference method. And this is all part of the plan. The plan should occur before you actually collect data. So here when it said in the study there were the results of 59 of 600, that does not come into play in the plan, right? That doesn't come into play until we get to the do section. So while that's important, we're going to put that aside and look at it later. So what are we going to do? What test? So if our conditions are met, we are going to perform And the name of this test, the name of this inference method is called a one-sample z-test for p. A one-sample z-test for p. So we're going to perform a one-sample z-test for p, where p is our proportion here. You need to include all three pieces when you're saying what you're going to do. Okay? Because eventually there will be two samples. Eventually it might be a z-test. Next section we're going to use it for means as opposed to proportions. So this is how you're saying what method you're going to do. This must be said. Okay? In the last section we said, what type of confidence interval we were going to do. Now we're saying what kind of test we're going to do. So let's go through our conditions. We should be used to these conditions by now. Random, normal, and independent. So let's walk through them. First condition is random. Well, did it say anything about that in the problem? Oh, yes, it did. A random sample of 600 American Idol fans is selected. So we can say that a random sample of American Idol fans was selected. And then there's another part here that's also random. It said that the order that the videos was shown was also randomly determined, so that is important as well. So I'm also going to mention that, because that takes into account another aspect of random. The order in which the videos were viewed was randomized for each subject. That's very crucial here. So random condition, check. Next condition, normal, right? We need to have it be normal so that when we calculate our test statistic, we can use Z. We can use these normal strategies. So when it's proportions, we need to check to make sure that something is greater than or equal to 10. You're always going to use the P from your claim, not your p-hat, not your sample data, right? Because I said the conditions should be able to be checked before you actually collect the data. So we need to check NP, and I'm going to put a sub-0 there just to show that it's from the claim. So N here was 600. My P for my claim was 1/12. 600 times 1/12 is 50. That's definitely greater than or equal to 10. And then if I do N times 1 minus P sub 0, that's 600 times 11/12, which gives us 550, also greater than or equal to 10. So we can assume that it is approximately normal distribution. Check. All right, condition number 3. We are testing for independence. Now, this was not an experiment, right? This was a sampling. So we need to check our 10% condition. We have to check the 10% condition in order to use our standard deviation of our sampling distribution, which comes into play when we calculate the test statistic. So my check for independence here, I would say, I might not be one of them, but I would say that there are at least 6,000 American Idol fans in the population, so our 10% condition is going to be met for that. So we can say it's reasonable to assume that there are at least, and then I'm going to show how I did the math. 10 times 600 gives us 6,000 American Idol fans. So the 10% condition has been met. Check. So now we actually come to the calculations. Get your calculator handy. For the do step, we need to calculate the test statistic, which that formula was given on the first page of your notes. And then we're just going to plug and chug. So our p-hat for this problem was our sample proportion, and then we found that there were 59 out of those 600 that preferred the last contestant. So I'm just going to go ahead and calculate that as a decimal because fractions can get a little icky. So 0.098 is that proportion. So now I'm going to go ahead and calculate my test statistic. In this case, we're calculating a z. So I'm going to copy the formula just so we see it here. We don't need to do this every time, but I'm just going to show you. To find your z, you take your p-hat, so your statistic from your sample. You subtract the p from your claim. And then your standard deviation of your sampling distribution using that proportion from the claim is what you are dividing by down here using our sample size. So let's plug everything in. Our p-hat was 0.098. 1/12, if you convert that to a decimal, is 0.083. And this goes there. 1 minus that. All over, what was my n? Oh, 600. Okay. Take a second, plug that in your calculator, right? It's one thing to know how to write it down. It's another thing to know how to actually put it in your calculator and get the correct solution. So, honestly, pause this video and do that right now. You should get a test statistic of 1.33. That is our test statistic. Woohoo! What does that tell us? It's kind of like a, standard deviation, how far you are from what you're predicting. In this case, our claim. So now we need to turn our test statistic into a p-value. Well, since we're using normal techniques, we're going to use normal CDF. If you want to use table A, by all means, please do, but I'm going to use the calculator. So, to get our p-value, I want to know the chance, the probability, that our test statistic is, now which direction do I want to go? Ooh, look at our alternative. We want it to be greater than. So the chance that it's greater than 1.33. So I'm going to use normal CDF. 1.33 is going to be my minimum. Some big number for my maximum. 0 and 1 for my mean and my standard deviation. Plugging that into our calculator, we get a p-value of 0.0918. Now, it's not asking you to interpret your p-value, but let's remember how to do that. Assuming that the null is true, right? Assuming that there is no preference for when it goes, there is a 9% chance that we would get a sample as large or larger than what we saw. Okay, so in this case, 59 out of 600. So now comes our last part, is where we conclude. We need to make a decision, and we need to state our conclusion. In your conclusion, you need to say 3 things. Compare your p-value to your alpha. Talk about what you're going to do with the null, and then say what you want to do with your alternative. Since our p-value is greater than alpha, and I'm actually saying our p-value is this or alpha was this, we are going to fail to reject the null. We never say we accept. We are failing to reject. That just means we don't have enough evidence to reject at this point. So then, here's our actual conclusion, right? There is not convincing evidence to conclude that there is an advantage to performing last in American Idol. So, 3 things in your conclusion. Compare your p-value to your alpha. Say if you're rejecting or failing to reject your null. In our case, we fail to reject. And then come to a conclusion about the alternative in the context of the problem. That's also crucial. There's an example on the next page. I want you to do that on your own, and then we will talk about it together in class. Best of luck.